Hello friends, welcome to VK Lectures. Let us do the next two questions from the Karnataka set 2021 physics question paper. Before going to the question, let us get the answers to the previous questions. This is 210, 201 and 021. These are the vectors. So you can write A is equal to 2i plus j plus 0k, b is equal to 2i plus 0j plus k, and c is equal to 0i plus 2j plus k. Now a cross b is I minus 2j minus 2k, b cross c is minus 2i minus 2j plus 4k, and c cross a is minus I plus 2j minus 4k. Now according to the formula, we have total surface area is equal to 2 times magnitude of a cross b plus b cross c magnitude plus c cross a. Now that's equal to 2 times root of a cross b 1 square plus 2 square plus 2 square, that is 144, so that's 9, plus root of 4 plus 4 8, 8 plus 16, that's 24, so root 24, plus root of 1 square 4 5 and 21. So this is the answer to this question. So total surface area. In the second question, we had the P4fx, the Legendre polynomial, and we are asked to find out the corresponding associate Legendre polynomial. Here we have associate Legendre polynomial. Now P4fx is given by 1 by 8, 35x to the power 4 minus 30x square plus 3. Now according to the question of the associate Legendre polynomial, we have P L m of x is equal to minus 1 whole to the power m into 1 minus x square whole to the power m by 2, and mth derivative of P L of x. So P4 of x, this is what we need. So the second derivative of PL of x or P4 of x is what we need. So P4 of x second derivative would be equal to 1 by 8. We have to differentiate this twice, 4 times 3 into 35 x squared minus 60 minus 60. So that's the first term. The last term that we have is here, the second derivative. So P4 2 of x, where m equal to 2, gives us 1 by 8 into 12 times 35, 7, 420. 420 x square minus 60 into 1 minus x square m by 2, so that is 1 minus x squared. So this gives us 1 by 8, 420 x square minus 480 times x to the power 4 plus 60. Yeah, sorry. Now here this is 420 x to the power 4 with a minus sign, and 480 x to the power with a plus, and this is x squared and minus 60. Here the question 3, for a greater than 0, the value of the integral, that is integral from minus infinity to plus infinity, cos x by x square plus a square dx is equal to. Now this is from complex analysis. Here let us take the function f of x equal to f of z is equal to cos z divided by z square plus a square. Now the function has the singularity. Now singularities means where the function is not defined. Now at when you put z square plus a square, that is denominator equal to 0, we do not have, the function is not defined at this point. Now when you set say z square plus a square equal to 0, it simply means z square equal to minus a square and z is equal to plus or minus I is the complex number. Alright, now since a is always greater than 0 as given in the question, we can take z is equal to plus IA. So this is our area of interest. Now we need to find out the residue of the function f of z at z equal to IA. This is what we need. So that's given by residue of the function f at IA is equal to z minus IA times the function f of z, that is cos of IA divided by z plus IA into z minus IA. Simply writing z square plus a square in this form, which gives us z square plus a square. Now that's here we need to include the limit z tending to IA. So limit z tending to IA, z minus IA times f of z, that is cos IA by z plus IA times z minus IA. Now applying the limits, even still you can cancel out these two terms. This residue becomes cos of IA by z plus IA. Now let us apply, so that's equal to z plus IA. Now we need to apply this limit z equal to IA. So let us apply this z equal to IA. What we are going to get is cos of I times A divided by z equal to IA. So IA plus IA is 2IA. Now we need the integral. So integral minus infinity to plus infinity cos x, so that is the question, cos x divided by x square plus a square dx is equal to 2 pi I, this is the formula, into sum over residues. Now there is only one residue, so that's equal to 2 pi I into residue is cos of IA divided by 2IA. So I gets cancelled, and 2 gets cancelled, so pi by A times cos of IA. So this is cos of I times A. And now let us see what is cos x. Cos x is equal to e to the power ix plus e to the power minus ix by 2. Now cos of IA becomes e to the power I times IA plus e to the power minus I times IA by 2. Now this gives us e to the power minus IA plus e to the power A by 2. Since we are dealing with the real part, that is the semicircle, that is when you consider this as the complex arena. This is from minus infinity to plus infinity. This is the circle we are talking about. We are not talking about whatever is in the towards the bottom part. So semicircle. So this can be written as this will go to e to the power minus I plus e to the power A by 2 will get cancelled. Now the question says our integral value of cos x divided by x square plus a square dx is equal to pi by A times e to the power minus A plus e to the power A. So this is the answer according to me, and possibly we can go with option D. Here we have a question from linear algebra. The question says that there is a 3 by 3 matrix A with the eigenvalues 1, 2 and 3. If E is then a 3 by 3 identity matrix, then which of the following statement is correct? Now from Cayley-Hamilton theorem, we can write the equation, characteristic equation A minus lambda times I, that is lambda is 1, so A minus 1 E, that is the identity matrix, into A minus 2 E into a minus 3e equal to 0. Now here a square minus this is 2ae 2ae, this is minus ae minus e squared, now plus 2e squared times a minus 3e equal to 0. This gives us a square minus 3a plus 2e times a minus 3e equal to 0. So this becomes a cube, then 3a squared with the minus sign. Here we have minus 3a squared minus 9a plus 2a plus minus 6e. Right, this is equal to 0. Now let's again rearranging it. A cube minus 3a square minus 3a square, 6a squared minus 7 okay, now we have this is minus 3a and minus 3, so that's plus, so that's plus 11a minus 6e, 6e equal to 0. Now let us multiply each term with a inverse. So we would get a square minus 6a plus 11e minus 6a inverse equal to 0. Now the 6a inverse is given by a square minus 6a plus 11e. Now a inverse is equal to a square by 6 minus a plus 11e by 6. So here according to the options we have a inverse equal to 1 by 6 a square minus a plus 11 by e. So option A is correct. Now trace of a is not equal to 12, determinant not equal to 12 because determinant is equal to lambda 1, lambda 2 and lambda 3, and eigenvalues, sum of eigenvalues is the trace, it should be sum. Here are few questions that you can try. The first question is evaluate the integral I equal to integral from minus infinity to plus infinity sin of x divided by x square plus a square dx, where a is a constant. The question number 2, consider a 3 by 3 matrix A with eigenvalues lambda 1 equal to 4, lambda 2 equal to minus 2 and lambda 3 equal to 1, and you are asked to find out the inverse of the matrix A using Cayley-Hamilton theorem. So you can find the answers and comment your answers below once you get. We will be discussing this in the next lecture.